Now we look at balanced and unbalanced forces. We start with balanced forces. Balanced forces refer to the resultant sum of all forces to be equals to 0. Okay, so the resultant sum is 0. If you look at the previous example 3.2d, that will be a scenario whereby the resultant force acting on the object is 0. So for resultant force that is 0, the object will not be accelerating. Acceleration will be 0. When we say acceleration 0, it can be two things. First, it implies that the object could be at rest initially. For that scenario, the object will continue to be at rest. Or it could be referring to an object that is in motion, that is the velocity not 0. So for object in motion, say a bus moving at a speed of 10 meters per second, it will continue to move at a speed of 10 meters per second because there is no acceleration. So it stays in the same speed and direction. That is actually Newton's first law, which we'll be looking at it under dynamics again. So in statement, Newton's first law states that every object continues its state of rest or uniform motion in a straight line that is constant velocity unless a resultant force acts on it to change its states. The states here refer to whether it is at rest or it is moving at constant velocity. Okay, so if there is a resultant force acting on the object, then the state will change, meaning object at rest will no longer be at rest. Okay, object that is initially moving at a certain velocity will change its velocity also. So that is Newton's first law. Okay, next we look at unbalanced forces. So that will be for your example 3.2a, b and c, where the total force acting on the system is not 0. So the vector sum of all the forces is not 0. Resultant force therefore exists. The resultant force is not 0. There will be an acceleration. So the mass or the object will accelerate in the direction of the resultant force, because the object will always move in the direction of the resultant force. So the acceleration must also be in the direction of the resultant force. This is our Newton's second law. We will look at it in greater detail when we do dynamics. Okay, now let's take a look at this book. Okay, the forces on the book are balanced. There are two forces, namely the gravitational force as well as the reaction force. Okay, but there's a mistake in the diagram. In the free body diagram for the book. Firstly, okay, the normal reaction force should be from the point of contact between the book and the table. Okay, this normal reaction force should pass through the CG, but in order to see the difference, I shifted it slightly out. Okay. Then the other force is your gravitational force. It must be from the center of the CG down. So please correct the notes. Next, forces acting on the person. This person, the forces acting are balanced. So namely, there are two forces. One again is the gravitational force. The other will be the reaction force by the floor on the man. So again, the two forces are not drawn properly. Okay, the normal reaction force should be from the point of contact. Okay, from the shoe here all the way up. It is drawn slightly away from the line of CG. Okay, because to see the two forces. The other force will be the gravitational force, which is the weight. Weight should be acting from the CG. Notice these two forces. If I call this N and I call this W, these two forces should have the same length because they are of the same magnitude. That's why the forces on the person are balanced. Okay, we take a look at the third scenario whereby we have a book that is moving on the table. So initially there must be a push. Okay, so initially you have given a push. So you use your hand, push the book, then the book is in motion. Okay, the direction of motion is this way. So the direction of the push initially is here. A horizontal push. So that the book moves horizontally. So when the book is moving, it will eventually slow down and come to a stop. Why is it like that? because the forces acting on the book are not balanced. Okay, we have the weight, which again should be from the CG down, balanced with the reaction force, okay, from the contact point up. But because the book is moving, we have friction. So this friction is not balanced by any force. Therefore, the resultant force on this book is actually the friction, and friction causes the velocity of the book to change. So here I'm drawing the direction of friction. It should be shifted down